Good morning, everybody. This is Mrs. Houts, and we are going to do the last part of naming and writing formulas for ionic compounds. Okay, so this is called type 2 binary ionic compounds. Okay, so here's a few definitions for you. Type 1 is actually what you've been doing for the whole past week. Okay, type 1 just means that you have a metal that only has one characteristic charge, and I'll show you the periodic table here in a second. Type 2 is this new kind, and it's almost identical. There's one little twist, and a type 2 metal is just a metal that can have more than one possible charge. Okay, and these are also called multivalent metals, and these are the transition metals. So this is going to answer the question, which I'm sure is keeping you up at night, about why those charges aren't written on the top of the families in the transition metal part of the periodic table. Okay, and this is why, because they can have more than one type of charge. Okay, so first let's just look at these type 1 metals. You've been working with these for quite some time now. The alkali family will always have a +1 charge. So if you have an ion, for example, of lithium, it will always be a +1 charge. Okay, it will not vary. All right, if you have an ion of calcium, right here, it will always have a +2 charge. And aluminum will have a +3 charge. So those are type 1 metals, and that's what we mean. So they'll always have their same characteristic charge, and we'll get into why they have those charges. I believe that's in the next unit. Okay, so we have that to look forward to. All right, these type 2 metals are these transition metals. So I put a big red box here around the transition metal part of the periodic table. The ones in green are the really most commonly used ones. We'll use those the most. And then there's tin and lead over here. So tin is SN and then lead. So these green ones we'll use a lot. And what it means to have more than one charge, all it means, for example, is copper is sometimes got a +1 charge and sometimes it has a +2 charge. Okay, so it varies depending on what it's bonded to. Iron can have a +2 charge or a +3 charge. Okay, so that's all it means. So they're multivalent, or they can have various charges. All right, and table F on the back of your periodic table, you can look at it at some point, lists the possible charges for a lot of these transition metals. I'm going to show you how to figure it out, sort of a different way, but you're always welcome to look at that table F on the back. All right, so we are first going to start out by naming ionic compounds that contain a transition metal. So point number 1 is that they're still binary, just like you've been doing. They'll have a metal and a non-metal. They may have a polyatomic ion, but they're positively charged and then have a negative charge. But in this case, the metal is a transition metal. And you can figure that out by finding the metal on your periodic table and seeing if it's in that transition metal area. All right, and then to name these things, it's really almost the same. You write the name of the metal, but then we got to figure out what the charge of the metal is, and I am going to show you how to do that using the charge of the anion. Okay, and then the new twist is that when you write the name, you have to tell the charge of the metal using Roman numerals. Okay, and I will show you how to do that. And then you just write the name of the non-metal and you change the ending to IDE. Okay, just like you've been doing. All right, so we're going to do a few practice problems, but I am going to switch to my camera and write these out because I think a lot better when I'm writing. Okay, so here is the directions when you're naming ionic compounds with transition metals. First we'll write the name of the metal, then I will show you how to use the anion to figure out the charge of the metal. Okay, so let's just do this first one. PbCl2. All right, Pb is lead, and it is right here. Right there. So that's a transition metal. So right away you know that you're going to need some kind of Roman numeral. So this is lead, and I'm just going to put parentheses there to put my Roman numeral in. Cl is chloride. All right, it's right here. It has a charge of -1. So lead something chloride. All right, and now when I say I use the anion to count the charge, I go like this. So Pb. All right, I like to make these tables to keep track of my charges. Chloride has a -1 charge, and I have 2 of them. So that whole negative side adds up to -2, which means that the positive side has to be a +2 because ionic compounds have to be neutral. All right, and then since we only have one lead here, its charge must be a +2. All right, and then this 2 becomes Roman numeral 2, and we stick it right into those parentheses. Okay, so that's where we get the Roman numeral. That's how we do it. All right, and I put this little table on here. I'm not sure if you know your Roman numerals or not. So Roman numeral 2 is what you use if you have a charge of +2 on your metal. All right, let's do another one. PbCl4. Well, this is lead again, and it's a transition metal, so I'm going to need a Roman numeral, so I'm going to put my parentheses there, and it's still chloride. All right, so let's figure out the charge on that lead using this chloride. I have 4 of them this time, so that whole negative side adds up to -4, which means my positive side has to be a +4. And again, I have one lead here, so it has to have a charge of +4. Okay, and then that charge gets put right into those parentheses. So Roman numeral 4 means that the metal has a charge of +4. All right, so then you go like that. Okay, all right, let's just do a couple more. MnO. Mn is manganese. It's right here. Okay, and O is oxygen, and it has a charge of -2. All right, so manganese is in that transition metal part of your periodic table, so you're going to need a Roman numeral, so put some parentheses in there. And oxygen, when it's an ion, is called oxide. All right, so let's figure out the charge on that manganese using the charge on the oxygen. All right, oxygen has a -2 charge. So the whole negative side is a -2. The positive side has to be a +2. And I only have one manganese, so it must have a charge of +2, which then becomes our Roman numeral. So manganese 2 oxide is the name of that one. All right, let's do one more. Mn2O3. This is manganese again. All right, and I need some Roman numeral and oxide. So let's figure it out using the charge on the oxygen. All right, again, oxygen has a -2 charge, but this time I have 3 oxygens, or oxide ions, I guess I should say. So that adds up to a -6, which means that the positive side has to be a +6, so that we have a neutral ionic compound. But this time I have 2 manganeses. I don't know how to say that. Plural. Okay? So each of them, you have to look. I got 2 manganese, they have to add up to a +6. So they have to each be a charge of +3, because 3 + 3 is 6. So then those charges, that charge of 3 goes right in there. Okay? And the name becomes manganese, Roman numeral 3 oxide, or just manganese oxide. Okay, so this is a good place to pause on the recording and go to that Google Doc, which is your ABA for today, and you can work on the first set of problems.